Do you guys know that there are more than 20,000 DDoS attacks every day? Today, DDoS attacks are one of the most feared attacks in the internet, especially for websites or internet services that do not have the capacity to fight these attacks. This is what happens when we experience DDoS attacks and what we have to do in order to mitigate these attacks. Alright guys, before we move ahead, let us know what DDoS means.
Here, an attacker uses several computers and servers in order to send meaningless data to a target server. Well, in this attack, a legitimate user cannot able to access the services from the online server. In our course project, we have created a RYU application which can identify and mitigate DDoS attacks. Now we are going to explain the algorithm we have used in our application.
Whenever a host sends a packet to the switch checks the flow table, and if there is a table misentry, the packet is forwarded to the controller. Next, whenever there is a packet in event taking place, our DDoS application parses the packet and looks up for the header information. Here, we have written a code in such a way that it checks for the source and destination IP address. After processing the IP header information of the packet, the controller will send a flow rule to the switch. Now, controller will send the packet out message to the switch, and then the switch forwards the packet as per the flow entry. So the question that arises now is, why we are taking IP address to drop the packets using that flow? If we use Ethernet address to drop the packet, then it would drop the packets from the genuine host along with the attacker. In contrast to this, if we use the IP address, then it would only discard the packets that are coming from the attacker and thereby forwarding the packets that are coming from the legitimate user.
In order to perform DDoS mitigation, we are accessing flow table statistics. Here, we are requesting flow statistics from the switch. Now, the switch sends the flow stats. From the flow stats, we will access the packet count data. After 3 seconds, we again request the flow statistics from the switch. Now, using the packet count data from the consecutive request, we will find the traffic rate of a particular flow. If the traffic rate is greater than the desired rate, we will add a flow to drop the packets using that flow. When another packet comes from the attacker, it will get dropped.
We have created a class called DDoS, which is inheriting appmanager.ryu app. Here, we are also initializing MAC to port data paths and also initializing some arrays that we are going to use in our code. Here, we have created a decorator to handle switch features reply and config dispatcher for negotiating of version. We are adding a packet misentry to the switch where packets with zero match fields are sent to the controller. Here we are defining add flow function. In this, we are sending open flow mod message to the switch to add flows. In this code, we have extracted Ethernet addresses in packet and added the entries in MAC to port table. Here we are obtaining IP address from the packets and adding the flows with IP and Ethernet match fields.
Event OFP state change detects the state of the connection. Dead dispatcher means the peer is not connected, whereas main dispatcher means the peer is still alive. Here, the monitor function is used to call requestStats function periodically. Here, the requestStats function sends OFP flow stats request. We have created a decorator to handle the flow statistics. From flow statistics, we will find the packet count data for the consecutive request. Using the consecutive packet count data, we will calculate the traffic rate. If the traffic rate is exceeding the desired value, we will apply actions on that flow.